Thank you. Can you all see me? I hope my camera is working.
We can see you.
Okay, great. So please, next slide. So I'm gonna, well, what happened there? There we go. I'm going to give you some information about the background that led us to using variable speed limits. I'm going to talk about the enabling legislation, tell you some of the methods that we're using, and then provide you some results. So please, next slide. I'm not seeing, okay, thank you. I don't want anybody to think that Wyoming is unique in the number of snowfall events we have. We look very similar to the rest of the country. Next slide, please. Same thing with winter severity. Certainly we have severe winters, but so does everybody else. Next slide, please. The thing that makes us a little bit unique is that we have a lot of blowing snow events. Where you see that kind of hot spot right in the kind of south central, southeast Wyoming, that's exactly where Interstate 80 crosses the state, and Interstate 80 in Wyoming is commonly comprised of about 50% truck traffic. Next slide, please. So those combination of weather events and a large number of trucks results in a lot of multi-vehicle crashes. Please, next slide. Next slide again. Not sure what happened there. What I wanted to let you know is that if there is a crash involving a passenger vehicle, especially when we come to these vehicles, a lot of truck traffic, the passenger vehicle really has no chance. So back in 2008, we had legislation go into effect that allows us to use variable speed limits for a weather or vehicle emergency. And again, it says we can use variable signs to do that. So next slide, please. We think of variable speed limits as a system of systems. We insist on having a road weather information system in a zone. We also have the sign itself, and then we also include speed sensing. And in our case, we are very rural. We don't have great communications. I know a lot of states are blessed by having a lot of fiber optic capability. Our emergency communications personnel have worked with us at length and have built basically a statewide radio-based network. So most of our systems are controlled by radio. Next slide, please. We built an algorithm that's largely based on stopping site distance, but it does include variables such as the weather conditions as well as speed conditions. Next slide, please. So what we're really trying to do is tighten up the speed distribution. As you can see, the green histogram there, if you look at the 100 on the left-hand side and the number of vehicles and intersect with the green, you'll see that in this mythical situation works out to be about 55 miles per hour. 100 vehicles are traveling, while 100 vehicles are also traveling 95 miles per hour. What we really want to do is tighten up that speed distribution. Next slide, please. The other thing we want to do is make the speed sensible for the roadway conditions. So we want to push that speed limit back and tighten it up. Next slide, please. This is real data. So in the top, you can see the ideal histogram. That was a dry and clear day. You can see that there's kind of a normal distribution of speeds. When the storm impacts, we see a large kind of spread of the distribution. So this is all data prior to having variable speed limits. You'll see that there's one vehicle traveling 32 miles an hour, while another one is driving almost 84 miles an hour based on that histogram. That obviously creates a lot of vehicle conflicts. So when we put a variable speed limit in effect, we see that speed distribution tighten up. And as the storm clears, we see it spread out, and we see the storm kind of move towards a normal histogram again. Next slide, please. One thing that we saw that was a problem for us is that we struggled to get the speeds raised properly. I think Utah said the same type of thing. So we've come up with some additional ideas to do what we consider a semi-automation process to be able to raise those speed limits more rapidly. Next slide, please. What we did is we came up with a way to integrate and automate. And again, we're talking about semi-automation. And the reason I say that is that we have our algorithm. You saw what it looks like. It's basically, like I said, based on stopping sight distance. We have our road weather information systems. We also involve our AVL. So if there is a vehicle, whether it's a patrol vehicle, and by the way, I should point out that patrol is part of WYDOT here in the state of Wyoming. So we allow for patrol officers and maintenance people to tell us you're wrong on this variable speed limit. So they can, if they're in the zone, we'll ask them. We had to come up with a process to be able to take the misfiring AVL information and the misfiring RWIS information, as well as any misfiring speed sensing data, to be able to exclude it. So we did that as well. And then we pushed that information with a recommendation directly to the Transportation Management Center. We have a process that we call the data broker. That information pulls from a lot of different sources and then pushes directly to a product from the state of Minnesota called IRIS. That's our Advanced Traffic Management System, which then turns that information directly to the roadside. So the TMC does see all the information. They have an opportunity to review that with a person on the ground, or they can just let it push automatically. If they don't act in a certain amount of time, the information is pushed directly to the roadside. Next slide, please. So this is what it looks like. This is the type of information that the TMC gets in what we call a track console. It's a transportation reports and action console that we wrote that tells them what the posted speed is, what the pace speed is, what the recommended speed is, and then they can, if they don't respond to this in a rapid amount of time, it pushes directly to the roadside systems. But they do have an opportunity to say there is a person in the zone, and we're going to be checking with that person before we actually push it to the roadside. Next slide, please. So we have 9 variable speed limit zones across the state. The first one kind of in that that army green color, that was placed back in February of 2009, directly after we got the legislation passed. Since then, we've been pushing this across a number of different hotspots. Interstate 80 in Wyoming is covered by about 45% of variable speed limits. So next slide, please. So I don't want anybody to go away thinking that we don't continue to have some multi-vehicle crashes, because we do. But the severity and the frequency has greatly reduced with variable speed limits. I think I'm right in saying that I know of one fatality that's happened due to a multi-vehicle crash in a variable speed limit zone in the last 15 years that we've been operating these. I could be wrong about that, but that's to the best of my knowledge. Next slide, please. These 2 crashes that I'm showing, can you go back one just for a second? I apologize. Can you go back one slide? This crash that happened, just hold that in your memory for a second. This happened in a variable speed limit zone where we had the speeds reduced to 45 miles an hour. Next slide, please. This crash happened about 1 mile away from a variable speed limit zone where we were not able to control speeds. You can tell the severity was much greater. We had no fatalities in the previous slide. This one we had a few fatalities. Unfortunately, people were trapped in their vehicles when the fire started and were unable to get out. So it was not a good situation whatsoever. I will tell you that the FHWA has also done some additional research. I think it's about 3 years ago they did a report. Just reading from one line of it, they said their analysis statistically found a significant reduction in large crashes, from 28.8% reduction in property damage only crashes to 65.2% reduction in rear end crashes. And then they also pointed out that the benefit cost ratio for these was about 9.05 for variable speed limits in the state of Wyoming. So that's what I have for you.